Right, guys, let's talk about how to run a linear regression in JASP. For the sake of this example, let's say that we want to test a potential confound. So let's say we want to know, or let's say we predict that drinking non-diet soda leads to a greater weight. Okay, and let's say that we want to know if height is a potential confound. In other words, is height a variable that we want to control for when examining the relationship between soda drinking and weight? So the first thing we want to do, whether you are running a linear regression for a confound or control, a mediation, or a moderation analysis, the first thing we want to do is run a correlation with our three variables, because if you don't have an initial correlation, you're not going to have a confound. You're not going to have a mediator or a moderator. So in this case, Q76 is soda drinking. So let's find Q76, move it over here. Q6 is height, and Q7 is weight. So as we see, all three of these variables are all significantly correlated with each other, so we can continue our analysis. So now what we want to do, let's go to regression, linear regression, and let's plug in our independent and dependent variables. So we know that our dependent variable is going to be weight, and so that is Q7. So let's put Q7 in dependent, and then our independent variable is going to be soda drinking, so that is Q76. So now we just want to assess for significance. So let's look over here. We're ignoring the intercept line, and we are just looking at Q76, p-value less than 0.05. Okay, we can move on. So now what we want to do, let's test our independent variable on our third variable. So we know that our independent variable, that's Q76, and our third variable is Q6. So let's take Q7 out, plug in Q6. Are they significant? Yes. Our p-value, again, is less than 0.05. And so now what we want to do is our third variable on our dependent variable. So let's go back and put Q7 under dependent and Q6 here. And then again, we have significance, so we can move on. If at any of these steps you don't have significance, you already know that this third variable is not going to be a confound. So what we want to do in order to see, now that we know that, okay, it looks like height could be a potential confound here, let's see to what degree, and let's test that out. So let's have our dependent variable, which is weight, here, and let's see what happens when we put Q76 back into the covariates box, and let's look at beta. So our beta, this is standardized. Beta is 0.052, and beta is the number that we want to look at, and we want to see if there's any change here. We're also going to be looking at our p-value. So we know that our p-value is significant. So when we add our third variable to this covariates box, if our p-value changes from significant to insignificant, so then 0.05 or above, we would know that our third variable is a full confound. So in other words, in that case, height would fully explain the relationship between soda drinking and weight. Now, if the p-value remains significant, but beta lowers, we know that we have some sort of partial confound going on, so that height would partially explain the relationship between weight and soda drinking. Now, if beta goes up and the p-value remains significant, that's something called a suppressor effect. No one in my classes had that result, so we're not going to go into that. So let's just look at the change between beta and the p-value when we add in that third variable. So let's go to Q6. This is a variable we want to potentially control for. And remember, we're looking at that beta 0.052. What happens to that beta and this p-value when we add in Q6? So we're looking at Q76. It looks like our beta lowered, and though our p-value went up, it still remains significant. So what this indicates is that we have a partial confound, that height is a partial confound. Now when you're looking at beta and p-value, we're ignoring this line, this Q6 line, this new line, we're ignoring that. We're just looking at this Q76 line. Again, we're ignoring intercept, and we just want to see the change in that beta and the change in that p-value when we add in that third variable. So that's basically it, guys. So again, to interpret this, we wanted to know, does soda drinking lead to an increase in weight? And does height account for that relationship? And it appears as if height accounts for some of that relationship, which makes sense. If we think that soda drinking leads to a higher weight, that would make sense because, you know, it's specifically non-diet soda. The more calories you're drinking, the more you weigh probably, but at the same time, the taller you are, usually the more you weigh. So it would make sense that height accounts for some of this relationship, and therefore, when you are analyzing this relationship, you would want to control for height. All right, thank you all for watching, and I will see you all in the next video.